Hey everybody, so we are going to be talking about triangle similarity. Now, triangles can be proven similar by three different ways. First is angle-angle similarity, right? And what that means is if that two corresponding angles are congruent, then the triangles are going to be similar. So we're going to see if the examples below are similar by angle-angle similarity. And if so, we're going to write our angle similarity statement. All right, so we see, oh, this one's pretty easy, right? We've got 75 and 31. You've got two angles are similar. So then we can say that A, 2, none, 1, 2, none, 1. So ABC is similar to 2, none, 1. All right, so what ends up happening is that's it, and you've got it. Now say, for example, if they hadn't given you that 31, but instead they'd given you, say, a 74 here, well, what you would always have to do is figure out what that third angle is in either of the triangles and check if these match or not. If they do, which in this case they would, you would still say that these are similar by these two angles, the angle-angle similarity. All right, but luckily they gave them both to you. All right, this one, if you're lost, then guess what? Don't forget, those vertical angles are back. These two are vertical angles, so that means they're always going to be congruent, which means that yes, by angle-angle similarity, triangle, I'm going to do none, 1, 2, and I'm going to do that same thing when I do none, 1, 2. Z, Y, X. I know we'd like to put it in alphabetical order, but sometimes that's not what's going to be happening when we're writing it with the corresponding angles, and that's okay. All right, your next one is side, side, side similarity. Pretty much, if all of the corresponding sides are proportional, then the triangles are similar. Right? So we are going to determine if these are similar or not. Let me make my pen a little bit smaller. All right, so we're going to determine if these are similar or not, and we have to figure out which ones are corresponding. For me, it looks like the 3 and the 6, and then the 4 and the 8. So I'm just going to set up my proportions. And I'm going to check if they all simplify to the same thing, which in this case, they do. So luckily that works out, and that's in fact our scale. So yes, by side, side, side similarity, triangles Q, P, and R are similar to triangle TSU. Let's go ahead and look at this next one. I'm not really seeing too much, but I do see these two. I remember that these two I can multiply by 7. And I see that I can multiply, these are multiples of 6. So I'm going to start with both of those. So I've got 30 over 24 is equal to 35 over 28. It's equal to 32 over 25. So 30 over 24, divide both by 6, you get 5 over 4. That's good. Divide both by 7 on the second one, and you get 5 over 4. Really good. Now, that's not going to be the case here. In fact, 32 and 25 don't have any factors in common because the factors of 25 are just 1, 5, and 25. So for this one, no, it's not going to be the case, and that's because CE is not similar to FH. So we're going to do the similar sign, but then put a line through it. That's what that means. You can also just type out is not similar to, or write out. All right, our last one is going to be side angle side similarity. So if two corresponding sides are proportional and the included angles are congruent, typically that's only one included angle, by the way, then the triangles are going to be similar by side angle side. So this one, we're starting off easy. We've already got our included angle in there. So I'm going to look right here, and I'm going to have 8 over 6, and that ends up simplifying to 4/3. Okay, so that's what we're looking for when we simplify 20 over 15, and that also simplifies to 4/3. Since both of these are proportional, we're going to say yes. By side angle side similarity, triangle JKL is similar to triangle MNP. Move this over, that way you guys can see. All right, here's our last one. And this one, again, super easy. We know that this is our included angle. We know which sides are corresponding. So it works out kind of nice. So what we're going to do is we're going to set up a proportion. And I'm going to just do the smaller ones over the larger ones, just because I feel like that's easier for my brain to think about. I've got 15 over 25. And is it equal to 12 over 21? Instead of multiplying those very huge numbers, don't forget, you can always simplify. So you get, let's see, 15 over 25 becomes 3 over 5. Divide both of these by 7, you get 4 over 7. So you already know that they're not proportional because they're not simplifying to the same thing. If you really wanted to, you could cross multiply and get that 20 is equal to 21, and that's not a true statement. So we just are like, no, that doesn't work, sorry. And we say no, the two corresponding sides are not proportional. All right, so those are the 3 different types of ways that you can prove that triangles are similar to each other. Now, what we're going to do is we're going to go through some different examples, and we're going to be answering those questions and going through them together. All right, so the first one we're going to do together, and you can tell which reason it's going to be, but just in case, we're going to double check. And I like to think about it this way. Since these are separated out, what is the scale factor that I'm using to multiply? And I notice that I can multiply both by 3. So then yes, by side angle side similarity, these two triangles are similar. So I'm going to say triangle EFG is similar to triangle RS. Oops, sorry, RTS. Because notice we went 1 included back to none, right? So right here, 9, and then included, and then back, so it becomes RTS. All right, next one. Well, we have an idea of what it could be because we've been given 3 sides. So we can set up our proportions. Let's see. Ooh, these two. Okay, this is 5 times 7. This is 5 times 5. These two, this is 4 times 4, and this is 4 times 7. So already we can see that there's not a common scale factor, right? But if we, but you know what? What if we found out that these two were not corresponding? What if these two were? And now that would work. So this would become, let's see, 7 times 5, 4 times 5, and that works. So let's see if these work. 25 and 22. We know that's not going to work. So no, these are not similar. And the reason that they are not similar is that VW is not similar to LM. Right? This next one, getting a little bit cut off, so I'm going to zoom out or scroll up. Let's see, we're just being given angle, so mark it up. Right, so we know that angle B right here has there we go, sorry about that. All right, has these two angles that are vertical angles, so they're congruent. We're only given 2 in each, so we're going to have to figure out what that third one is. 53 minus 42, 53 and 42 minus 180 is going to get us the answer of angle E. And when I type that into my calculator, I get 85. Well, now I know that these two are congruent, so I can move forward. So, lucky for me then, I can just say, oh, this is by angle similarity that these two triangles are congruent. And it's going to be triangle ABE is similar to triangle DBC. All right, next one. Notice that on this big triangle, that entire length is 24. On this big triangle, it's going to be 20. So set up your proportion. I've got 15 over 20, 18 over 24, and 12 over 16. And let's determine if that is going to be similar or not. So if you've checked it, you notice that all of them simplify to 3 over 4, which means that triangle QRP is going to be similar to triangle XYP by side, side, side similarity. All right. We kind of had nothing here, huh? It looks like. But don't forget those parallel lines and those transversals that you guys love so much. So I'm going to help you guys out. These two are parallel. And they're intersecting the transversal at the same angle, that means. So these two are going to be congruent. Same thing can be said here because of this other set of parallel lines. You have two angles that are congruent. Therefore, you can say that angle-angle similarity proves that these two triangles are similar. And you're going to say that triangle JKN is similar to triangle KLM. And it's really that easy. All right, so I'm going to have you guys do this one. Don't forget to add up all of this to get the complete side. All right, when you end up doing this, this is not similar. And the reason is because both corresponding sides are not proportional. And we could have proved that by just the ratio that you probably had set up. Oops. Simplified to 6/11, didn't it? Divided both of those by 4 and both of these by 5, and you got non-equal ratios, and therefore proving that proportion wrong. All right, I want you to try this one. This one's an angle one. Don't forget to check that third angle on each. All right, so this one is not similar, and the reason being is that angle Y, right here, that would be 39. This is 34. So because you do not have two angles that are similar, then no, it just doesn't work. And in the other case, you don't have a side angle side situation, so that one also doesn't work. All right, angle 8. So right here, you've got all of this set up. Well, don't forget, these are vertical angles. So we got to think about it two ways. Maybe 39 and 63 are the ones that are corresponding. Or maybe it is just how it is, and 39 and 84 are corresponding. So I'm just going to use my calculator and cross multiply and check the cross product. When I do 39 times 63, I get 2457. All right, and then 84 times 52 is 4368. So that one does not work. So let's try it with the other one where they're swapped right here. So 39 over 63 with 52 over 84. And when I put these both in the calculator, I get 3276 and 30 for both of these. So yes, this is what's going to end up working. And now we know which ones are corresponding. So yes, by side angle side similarity, triangle SRQ is going to be similar to triangle TRU. Remember, TRU was with SRQ. You have to go swapped. So it's good to mark up your corresponding sides there. All right, lastly, you've got a word problem. Whenever you've got something like this, draw a picture, y'all. All right, so 1.4 meter tall child is standing next to a flagpole. Okay, I'm going to draw my little child. Woo! He's 1.4 meters tall, and he's standing next to a flagpole. Woohoo. The child's shadow is 1.2 meters long. And at the same time, the shadow, I'm just going to draw it under, even though, it's going to be overlapping in real life, is 7.5 meters long. So how tall is the flagpole? So let's draw two triangles right here. You've got 1.4 meters and 1.2 meters. You've got an included angle here. So it's going to be with side angle side that these two are similar. But you don't know what that total length is, or sorry, height is of the flagpole. You know what the shadow is. So you're going to set up a proportion. And I got 1.4 over 1.2 equals x over 7.5. Cross multiply and solve for x. And when you do that, you get that the flagpole is 8.75 meters tall. All right. Thanks for watching.